few of the problems from last night's homework, and then I'll give you today's lecture. Okay, last night's homework, you had some proofs to do. So what was that? Okay, I'll do 53 then. No, I'll do 51. So that's tangent. Tangent of pi minus theta equals negative tangent theta. So prove this identity. So get rid of the equal sign, make the bar. And then the left side of the equation, there's only one thing you can do here, is expand using the identity. So tangent of the first minus tangent of the second all over 1 plus tangent of the first times the tangent of the second. But we know that tangent of pi is 0. So we get 0 minus tangent theta all over 1 plus 0 times tangent theta. So basically you got negative tangent theta all over 1, which is negative tangent theta, which is the same as the right side. Quite easily done. So you just simply apply the identity and you got it already. And then let's look at one of the tougher ones, 56, 57, 59. Yeah, let's do 59, since that's the last one. 59. Cosine alpha plus beta all over cosine alpha cosine beta is equal to 1 minus tangent alpha tangent beta. Alright, so erase the equal sign, put the bar. Okay, now on the right side, you probably again want to change everything to sines and cosines, yeah? So this is sine alpha over cosine, and this is sine over cosine beta. And then if you make a least common denominator, what are you going to have on the top? This is like 1 over 1, yeah? So you're going to have cosine alpha cosine beta minus sine alpha sine beta. And then look, you can kind of see it's right there already, because the identity for this is cosine alpha cosine beta minus sine alpha sine beta all over cosine alpha cosine beta, and that's exactly the same thing. So thought it was going to be longer, but it wasn't. QED. So simply apply the identity. So for Monday's quiz, again, you got to make sure you memorize all of these identities, because that's going to be key. Okay, now today's lecture is on the double angle identities. Okay, so what we need to do is we need to derive identities for cosine 2 theta, sine 2 theta, and tangent 2 theta. We call these the double angle identities because it's double the angle. Okay, now for cosine 2 theta, okay, you know what? I'll just derive them all. Cosine 2 theta is equal to cosine of theta plus theta, right? 1 theta plus 1 theta is 2 theta. Now, the reason why you want to do that is because we know how to expand cosine of something plus something. So if I expand that, you get cosine of the first, cosine of the second, minus sine of the first, sine of the second. And then cosine times cosine is cosine squared. Sine times sine is sine squared, and there you go. That's the identity for cosine 2 theta. Now, if you look at my identity sheet in the book, you notice that there's 3 identities. Yeah. Okay? So, how do you get those other 2 identities? Well, by using the Pythagorean identity. So, once you have this one, what if I were to replace sine squared theta with, what is sine squared theta equal to? 1 minus cosine squared theta, right? The Pythagorean identity. If you distribute the minus sign, you get cosine squared theta minus 1 plus cosine squared theta. And cosine squared plus cosine squared is 2 cosine squared theta minus 1. And there you go. That's another one. Now you might be thinking, how come we have more than one? Well, sometimes it's easier to use one than the other. That's why in certain problems. Okay, now can we derive one with only sine? Yeah. Replace this with 1 minus sine squared theta. So let's go down here. So you got 1 minus sine squared theta minus sine squared theta, and that's equal to 1 minus 2 sine squared theta. And that would be the other one. So if you ever forget these identities, you can always just derive them, like I'm doing. But ultimately, you want to have them memorized so you don't have to worry about deriving them and reinventing the wheel. So to derive all of these identities, notice what we're going to do. We're just going to split up 2 theta into theta plus theta. So let's do sine 2 theta now. Sine 2 theta is equal to sine of theta plus theta. And what's the identity for that? Sine of the first, cosine of the second, plus cosine of the first, sine of the second. But armadillo plus armadillo, right? But they're both the same thing, is 2 armadillo. And there you go. 2 sine theta, cosine theta. And finally, the last one we have to derive is tangent 2 theta. We're going to do exactly the same thing. We're going to split up 2 theta into theta plus theta. So tangent of the first plus tangent of the second, all over 1 minus tangent of the first, tangent of the second. Tangent plus tangent is 2 tangent. Tangent times tangent is tangent squared. And there you go. 2 tangent theta all over 1 minus tangent squared theta. So these are the double angle identities. You have them on your identity sheet. It's printed in the book. But like I said, ultimately we want to have these memorized. Now, what kind of problems can you expect to see tonight? Well, one of them, first of all, you got to recognize identities. Okay, I'll give you one. How about something like this? Cosine squared 15 degrees minus sine squared 15 degrees. Now, there's 2 ways to do the problem. We can actually compute the cosine of 15 degrees because we did that on the previous night's homework, right? From 8.4. Right, because we can split up 15 into 45 minus 30, and we can do the same thing with the sine, but that takes a long time, right? We don't want to do that. And then you got to square each one. It's a long process. An easier way would be to go, hey, use somebody, right? Look, cosine squared theta minus sine squared theta, right here, is equal to cosine 2 theta. So this is equal to cosine of 2 theta. And of course, 2 times 15 degrees is 30 degrees. Okay, and that's a number I'm supposed to know. Root 3 over 2. Yeah, so these problems help you recognize identities. Okay, I'll give you another one. 2 tangent of pi over 12. Let's do some radians here. All over 1 minus tangent squared pi over 12. So to compute the tangent of pi over 12, which is 15 degrees, in the previous section we would change that to 45 minus 30 and expand. But like I said, that's a lot of work, so maybe we don't have to because, hey, use somebody. Right here, look. 2 tangent theta all over 1 minus tangent squared theta, which is this, is equal to tangent of 2 theta. So this is equal to tangent of 2 theta. And if you multiply 2 times pi over 12, you get pi over 6. Hey, that's a number I'm supposed to know. Tangent of pi over 6, root 3 over 3. Boom! See, so both of these, they look exactly like that. But then sometimes you gotta like do a little more work. Like, what if you had a problem like this? What is cosine of 15 degrees plus sine of 15 degrees quantity squared? And again, like if you want to, each of these, you could go 45 minus 30, 45 minus 30, and then expand. That takes a long time though. Maybe there's a faster way. Yes, multiply it out. Now, if you multiply this out, in fact, on your quiz, some of you had problems multiplying out. No, if you have a plus b squared, that is not a squared plus b squared. It's a squared plus 2ab plus b squared. You need that middle term there. Okay, so a plus b squared would be the first one squared, so cosine squared 15 degrees, plus 2 cosine 15, sine 15, then plus sine squared 15. So that's how you expand it. And then look at this, cosine squared plus sine squared. Hey, you somebody. That's 1. And then this thing, that's another somebody. Look, it's this one right here. 2 sine theta cosine theta. You somebody is sine 2 theta. So this is the same thing as sine of 2 theta. Theta is the 15. And then if you multiply 2 times 15, you simply get 30 degrees, and that's a number I'm supposed to know. Sine of 30 degrees is 1/2, and so you get 3/2 as your final answer. So that's the kind of problems you're going to see so that you directly apply the identities like that. Now, another problem you're going to see is, where you're going to draw the triangle in the proper quadrant. I'm going to erase this. I'm going to leave the identities up so you can see them. Something like this. If sine of theta is equal to 4/5, and theta is between pi over 2 and pi, which means in the second quadrant, compute, A, cosine 2 theta, sine 2 theta, and tangent 2 theta. So before you even start, you want to draw the triangle in the proper quadrant. So if you are between pi over 2 and pi, you are in the second quadrant. Here's theta. Sine is opposite over hypotenuse. And then you use the Pythagorean theorem. So 3, 4, 5 again. And then put the correct signs. This one is negative because you got to go left. That one's positive because you got to go up. And the hypotenuse is always positive. Okay, now, how do you compute cosine 2 theta? Well, cosine 2 theta, you can use any one of these three. It doesn't matter. They're all equal. So, like I have my favorite. My favorite is the first one. Cosine squared theta minus sine squared theta, but some of you might go, yeah, but Mr. Park, since they give you sine theta, shouldn't you just use that one? Yeah, but it doesn't matter because they all give you the same answer. So if we use this third one, 1 minus 2 sine squared theta, so that's 1 minus 2. Now remember, sine squared theta means sine theta quantity squared, right? And sine theta is 4/5. It's given. Or you can look at the triangle and go opposite over hypotenuse, and you still get 4/5 no matter what. And so you get 1 minus 2 times 4/5 squared, which is 16/25. So that's equal to 1 minus 32 over 25. And that's 25 minus 32 over 25, making a least common denominator. So your final answer is negative 7 over 25. Woo! A lot of computation. Now, like I told you, it doesn't matter which of these identities you use. What if I use that first one? Then I would go, let's make another line here. What if I use this one, cosine squared theta minus sine squared theta? Am I going to get the same answer? Yes, you will. So cosine theta, if you look at the picture you drew, is adjacent over hypotenuse, negative 3/5, squared, right? Minus sine theta, which is opposite over hypotenuse, squared. And then you get, what is that? 9/25 minus 16/25. That's negative 7 over 25. That's the same answer. So you can use whichever identity you want for cosine 2 theta. Sine 2 theta. Now, sine 2 theta, there's only one identity. And same thing with tangent. You have no choice. 2 sine theta cosine theta. So all you have to do is look at the triangle you draw and fill in the value. So 2 times sine theta, look at the picture. What is sine? opposite over hypotenuse. Cosine is adjacent over hypotenuse. Multiply out those numbers. This is like 2 over 1, so what is that? Negative 24 over 25. Easy. The key is drawing the triangle in the proper quadrant. And tangent 2 theta, there's only one identity right there. 2 tangent theta all over 1 minus tangent squared. And then all you have to do is look at the triangle you drew. So what is tangent theta? Opposite over adjacent. So negative 4/3. Right, and tangent squared means tangent quantity squared, yeah? So what do we got? We got negative 8/3 over 1 minus negative 4/3 squared, which is 16/9. And again, when you have fractions within fractions, multiply top and bottom by the least common denominator, which is 9. And you're going to get 3 goes into 9 3 times, so you get negative 24. And this 9 got to be distributed down here, so 9 times 1 is 9. Minus 9 times this, the 9's cancel out, get 16. So you get negative 24 over negative 7, which is positive 24 over 7. Now some of you are probably thinking, well, I don't know. Some of you are probably thinking, Mr. Park, if you got cosine and sine 2 theta, then to get tangent 2 theta, can't you just go sine over cosine? Yeah, you can. But I'm just showing you how to do it using the identities, because that's the exercise of this section here. Okay, and the last kind of problem you're going to see is you're going to have to do some proofs. Okay, I'm not going to look at the book, I'll just make up my own here. I'm just going to do one kind of medium difficulty one. Prove sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. So let's take the bar. Okay, so we don't have to worry about changing everything to sines and cosines because it's already sine. So, Mr. Park, 3 theta, this is 2 theta. Oh, how are we going to get 3 theta? Well, you got to figure out, okay, what can I do with 3 theta? Well, break it up into 2 theta plus theta. Right? Is it 2 theta plus 1 theta, 3 theta? And why do you break it up like that? Because 2 theta and theta, we know identities for them, right? Like on tonight's homework, I think you're going to get cosine 3 theta, so you do the same thing. And you might have a 4 theta, then you go 2 theta plus 2 theta, right? You break it up into things that you know. Okay, now what's the identity for sine of something plus something? Sine of the first, cosine of the second, plus cosine of the first, sine of the second. You just use, that's the sum identity that we learned. Now, notice that, look right here, I have sine 2 theta and cosine 2 theta. That's the double angle identity. So, sine 2 theta is right here. And again, you have your identity sheet. Use it while you do your homework, but ultimately, you gotta commit these to memory now. Is 2 sine theta cosine theta times cosine theta. Oh, we're gonna need more room, so let's make the line go like this. Plus, now cosine 2 theta, see, this is where you gotta think. There's 3 different identities here. Which one am I gonna pick? Well, if you look at the right side of the equation, the right side of the equation only has signs in it. There's only signs. So, which of these 3 here has only signs? That one. So that's the one you want to use. 1 minus 2 sine squared theta. See, if you're going to make the left side the same as the right, and if there's only signs, you got to make all signs. Now look at what we got so far. So we got 2 sine theta. Cosine times cosine is cosine squared. And if you distribute the sign here, you're going to get sine theta minus 2 sine cube theta. See, it's starting to take shape. Yo, but Mr. Park, there's only signs over there, but I still got a cosine here. But that's easy, right? Because what is cosine squared theta? Huh? Pythagorean identity? 1 minus sine squared. Right? Because we want to change everything to sines. Okay, and then if you distribute this over here, you get 2 sine minus 2 sine cubed plus sine minus 2 sine cubed. And then if you combine the like terms, 2 plus 1 is 3. And then negative 2 and negative 2 is negative 4. And there you go, look, left side, right side, same. Quite easily done. This is called the triple angle identity. You don't want to memorize, I mean, if you want to memorize it, you can, but it's not worth it unless you're on the math team. But you do have to have the double angle identities memorized. All right. So you should be able to do your homework now. Good. Bye.